All right, so the shortcut of determining their integration is eyeballing it. We're gonna eyeball it, but I'm gonna teach you how to. But it depends on how much you're familiar with the spectrum. Okay, so I can do it now, but you guys can't it because you haven't seen it often enough. But we'll try. I'll just introduce this to you. Okay. All right. So first off, so we have 8 hydrogen total. How do you divide it into 3 signals? There are 3 signals in here. Well, you're gonna think about 2, 3, and 3. 1, 6, and 2. I don't know. Do something that makes sense, right? So I can see that these three, the step right here, the height of this step and the height of this step are equal. This, the height of this step a little bit smaller. So I'm gonna guess that it's gonna be 2H, 3H, and 3H. Total is 8 protons. That's how I do it. You can actually eyeball that. All right. I'll try this one. Let's say we have 8 protons again. I'm gonna go with maybe 2H right here, 3 and 3. These are the same height, right? This one is smaller, so I'm gonna go 3, 2, and 3. Yeah, right. You can do that. All right, larger number of protons. It's gonna be quite a little bit more difficult, but I mean it's possible. I'm gonna guess. So we have 14 total. Let's guess it. Let's try to guess it. So we have 2H. Maybe 3H, and the rest 5. So the rest is 9H. Maybe so triple of that. Okay. Now some of you may think, hey, how do you get 9H? How do you know it's actually 9? Well, because I know about this common integration ratio. No, because there's a specific way the carbon and hydrogen can form bond, right? And that you get these common alkyl groups, and they have their own integration. For example, an ethyl group, we have 2H and 3H right there. If you have an ethyl group, you're going to say 2H and 3H. In isopropyl, you're going to have 1H and 6 H's. Yeah. In third butyl, no hydrogen in the middle, but there's 9 H's, right? You saw earlier there's 9 protons. That's possible. Now you're not going to say like 1 to 4 to 7. You're not going to see those numbers, but you see 2 and 3, 1 and 6, 0 and 9. In mono substitute benzene, so you depends on symmetry, but you're going to see like 2 and 3, thing like that. The chemical shape of the proton on benzene are really close. Sometimes they all overlap. You can't really see anything. You get 5 H's. Okay, like these two type of protons. So we have this one type, another type right here. It should show different signal, but I mean, if it's really close in chemical shape, the location, they just add up to like to one signal, and you get a 3S right there usually. Okay, in a para disubstitute benzene, there are 2 type of proton. You're gonna see 2 and 2. All right. Try one more time. So just keep practicing. See this very often. Again, 8 H's, 8 protons. So we're gonna go 2, 3, and 3. Yep, 2, 3, and 3. So 8 total. This one also 8 protons. Okay. All right. What we get? Exchange with D2O. It's kind of tell you, hey, that's an either OH or NH. Okay, OH or NH. If you remember the chemical shape, so NH is 1 to 3 ppm. The OH anywhere from 2 to 5 ppm. Okay, maybe 2, a little bit less than 2. This one is actually an OH, and you can know it right away. That's 1H. All right. So if this were to be 1H, the integration, the height right here, similar. Right. I'm gonna go with 1H as well, and the rest is 6 H's. What is this? This is actually an isopropyl group 1 and 6. Yeah. Try one more time. I'll try one more time. This one, 10 hydrogen. Oh, all the 9 aromatic region. That's 7 to 8. All right. Let's see what we got. Okay, this one is 2. The whole thing right here looks like a 3 to me. If you can divide it, that's like 1 and 2, but it's gonna be difficult. So we're gonna do 2 and 3. The whole thing here. This step right here is 3. Well, but we have 10 hydrogen total. Maybe 2 benzene ring. You got 4 and 6. That's possible. All right. So the eyeballing is it depends on how much you're familiar with the spectrum. If you're not familiar with it yet, well, use a ruler. It's fine as well. But once you get to see more and more spectrum, this one will become a little bit more handy. Okay. The integration doesn't have to be just the stair that you saw earlier, right? The integration should be could be found right here. Under the peak. Yeah, I can. This NMR spectrum show the stair as well, the different height of the stair, and also show the actual integration of each stair. I give you a number right away. So 3 proton, 2 proton, 4 proton, 2, 3, and 2. Right? Some of the this one show a stair up here, right? But also show the integration down here as well. 3 proton, 2, 2, 2, and 2. That's integration. All right, move on to one more information of from proton and neutrons.